ठीक है, तो आज हम बात करने वाले हैं नेटफ्लिक्स ओएसएस के बारे में। नेटफ्लिक्स ओएसएस स्टैंड्स फॉर नेटफ्लिक्स ओपन सोर्स सॉफ्टवेयर। नेटफ्लिक्स एक यूनिक सर्विस है जहां पर वो बहुत ज़्यादा कंटेंट डिलीवर करते हैं, मूवीज डिलीवर करते हैं। देयर आर लॉट ऑफ यूजर्स दैट दे हैव एंड द ट्रबल दैट दे फेस्ड इज अपस्केलिंग। अपस्केलिंग का मतलब होता है नंबर ऑफ यूजर्स जब हमें इंक्रीज करने होते हैं किसी एप्लीकेशन पे। um, uh, तो वो कैसे करें? दैट स्टेप इज नोन एज अपस्केलिंग। Why is upscaling important? Upscaling is important because business revenue depends upon the number of users that you have. Your services improve when you are able to cater to multiple users, and because that is the number of times your application is being tested, and then you are resolving them. Okay. आपका रेवेन्यू बढ़ेगा, आपकी एप्लीकेशन स्ट्रांग होगी, आपका इंफ्रास्ट्रक्चर स्ट्रांग होगा जब आपके पास ज्यादा यूजर्स होंगे। कंपनी की वैल्यू बढ़ेगी जब उसके पास ज्यादा यूजर्स होंगे। एंड बिजनेस ड्राइव्स टेक्नोलॉजीज। So when Netflix was working on such an architecture to resolve this complexity of upscaling, they face a lot of issues, and they studied it very well. They studied it very deep. They invested a lot of money, a lot of effort, a lot of R&D went through it, and then they realized, okay, this solution works for them. Okay, so they worked on it, they used it, and then they open sourced it after some time, which is known as Netflix open source software. ये माइक्रो सर्विसेज पे बना हुआ आर्किटेक्चर है, और ये हमारी बहुत सारी माइक्रो सर्विसेज की प्रॉब्लम सॉल्व कर देता है बहुत इजीली। हम बात करेंगे इस नेटफ्लिक्स ओएसएस के बारे में आज के सेशन में। मोनोलिथिक एप्लीकेशन। मोनोलिथिक, मोनो का मतलब होता है सिंगल, लिथिक का मतलब होता है स्टोन। तो एक सिंगल स्टोन टाइप की एप्लीकेशन जो होती है, जिसपे हम अपनी एप्लीकेशन की लगभग सभी चीजें डाल देते हैं। फॉर एग्जांपल इट्स यूजर इंटरफेस, उसकी बिजनेस लेयर, उसका डेटा इंटरफेसेस, बेसिकली व्हाट यू कॉल हाइबरनेट, राइट, which allows you to talk to the database, any system like hibernate. आपके सब सर्विसेज, सब UI layer, everything is bundled together as a one strong rock solid application. If we talk about Java terms, yes, it could be a war, it could be a jar, but it's a single deployable item. ये आप कस्टमर को दोगे, कस्टमर उसको डिप्लॉय करेगा और उसको यूज करेगा, राइट। तो ऐसी एप्लीकेशंस बनाने में काफी सिंपल रहती हैं, इनको मैनेज करना आसान है और एक सिंगल डिप्लॉयबल की तरह अवेलेबल रहती हैं। एंड दिस हैज बीन इन यूज सिंस द स्टार्ट ऑफ अवर आई थिंक सॉफ्टवेयर प्रोग्रामिंग। हम अपनी एप्लीकेशंस को एक सिंगल डिप्लॉयबल की तरह रिलीज करते हैं एंड देन पीपल यूज देम, राइट। So these kind of things work in most of the cases. They are good and they are fine, but they have couple of problems. The first problem that they have is the items inside them are very tightly coupled. जो आपने UI बनाया है वो आपके डेटा मॉडल के साथ बहुत ज़्यादा टाइटली कपल्ड है। फॉर एग्जाम्पल इफ यू टॉक अबाउट GSP, आई एम नॉट टॉकिंग अबाउट एंगुलर एंड स्टफ, but if you talk about GSPs, your GSPs are very tightly coupled to the model that you have, right? If you talk about different services, they are linked to each other, they are tightly bound with each other. uh, so उनमें अगर आपको कुछ कुछ फीचर्स ऐड करने हैं, it becomes very difficult to add new features. They are bound with each other. दूसरी चीज को ब्रेक किए बिना आप अपनी एक सर्विस को एनहांस नहीं कर सकते। Moreover, upscaling an application like this, where everything is tightly coupled, where everything is like a rock, right? You have to replicate the same application again and again. So just imagine that if this application uses, let's say, 4 GB of RAM, to replicate it to 2 instances, you would need minimum 8 GB of RAM. Obviously, there would be some ad hoc tasks for managing the load and everything in between. But yeah, so minimum of 8 GB RAM would be required to replicate that stuff. To solve one problem, which is of tight coupling, we enter another architecture which is known as service-oriented architecture, or SOA. I think many of us would have already worked with SOA architecture. Mind you, this is still a monolithic architecture. It's just layered. So what we do is, according to the business requirements, we have a different layer which is serving their own business services, business processes. For example, we might have a login service somewhere here. We might have accounts or transaction service in this layer, which is doing it in their own job, which are horizontal. But if we see the vertical items, these are some services which are used all across the different services that we have. And these services are maybe the part of all of them. For example, authorization. If we want to call a service, we need to check if the person is authorized to invoke that service or not. So these are the security and maybe auditing as well. If you want to govern what things are happening, you would like to keep some things outside the application in some external system or maybe a repository. This service is working vertically all across the different business layers. This kind of an architecture where we have a database where the services store the database there, they have multiple layers, but they are doing only the stuff that they have, is known as service-oriented architecture. They create a highly modular application which all the business services are loosely coupled. They are separate from each other. Point to be noted here is that this is still monolithic application because this is a single deployable. I've seen many times that uh, ev- even in so architecture where we have modular services, we have modular data layer and everything, databases are common. So for example, let us say I want to get the accounts for a given user. A simple query like select star from accounts where user ID is the person's user ID, which maps to the user ID table. You have a foreign key there, and a simple query would fetch you all the accounts, right? So this is pretty fast. This is pretty cool, and it's still easier to manage. Not as easy as the monolithic application, definitely, but there are some laws and some rules that need to govern through architecture. But still, uh, it gives you good flexibility there. But since this is again monolithic application, it is difficult to scale. Okay, if it is you cannot have your own database, each service does not have that database. There can be database interactions, which means you might have achieved loose coupling in this layer, but the data layer is still tightly coupled, right? So this is a problem with SOA architecture. When you To solve these two problems, the difficult to scale and to have loosely coupled, Netflix or many other big companies like Amazon entered the microservices architecture. In microservices architecture, they have individually deployable microservices, individually deployable components which you can deploy on your own server. These services have their own databases. They deploy on their own. They have no linkage with even with the database. So this is something which is counterintuitive. Okay. Um, when Now imagine earlier when the database was common, you could have easily fetched data from another table, right? Let's say we have accounts. We can very easily go and fetch data from login table, from users table, or maybe any other thing which is not related to this service, but still you can get the data, and that data transfer is many times required. So that was easy. But in case of microservices, that is not at all possible because the general phenomena is to have a different database itself. It could be a separate schema, it could be a separate database itself. It could be a different type of technology. One could be MySQL and another one could be NoSQL. So a completely different type of database system these services might have. So there is no chance of these two microservices sharing data via database system. So that thing is broken down. However, these microservices can talk to each other via APIs, and the general trend these days is to use REST APIs. It's possible to have a SOAP-based microservices architecture. But nobody prefers that these days. RESTs are the best suited, and I don't think people have experimented much with SOAP. So yeah, REST is the way to go. We go with the REST APIs, simple, smooth, and cooler to use. This is on a high level our microservices architecture. So microservices architecture solves the problem of scale. They solve the problem of loose coupling. However, this architecture is very, very complex. If you see, something which worked for me in monolithic architecture as a single block now requires a lot of different microservices to, to achieve the same business behavior. When we have increased number of microservices, there is definitely some impact on managing of those microservices. It was a if this was a monolithic application, it was a simple Java method call. But now this becomes a REST API call, which means there are nuisances of the network. Network will break down. Network is going to be slow, respond late. कुछ microservice बैठ भी सकते हैं. It's not responding in time. So all of those things we need to handle. And now, because when we were using a monolithic application, everything was in the same technology, right? Everything was Java, everything was Golang, or whatever technology that was. But that was one technology. अगर आपको कुछ problem आ रही है, you go with to the another developer and ask get the solution done, and it works well. But in case of microservices, even the technologies are not guaranteed to be same. So one technology, one microservice could be written in Java, another microservice could be written in Golang, and they would work well. Nobody will get to know until unless our contract of the REST API is meeting, and that is what we are looking for. That's what business needs. So there are a lot of advantages of microservices, but it's not for everyone because it comes with a cost. Let's talk about what are the advantages of microservices. They make our application technology independent, which means that, let us say, Amazon is not into food delivery system at the moment, and they would like to enter food delivery system. So there is a new CXO who joined Amazon and says, okay, we are delivering where we good stuff. Why not let's start delivering food as well, right? I need an application. I need my application, Amazon.com, to support food delivery systems as well. So the people should be able to order food from there and start delivering that. Technically, that might be a bit challenging. When there is a CXO in the system, he has a timeline in mind. He needs to start delivering within 2 months, because if he does not deliver within 2 months, Zomato will take over, or maybe some other company will take over. So the timelines are very important. So let's say he gives us the target of, let's say, next 2 months, where we need to start delivering food via app, and we need to make all those changes. So what's the general process? We will raise a requirement. The requirement will go for some approvals, and then it will go to the hiring team for hiring the right people. But at this moment, hiring team realizes, oh, all our application has been built in Golang. We're not finding Golang people anymore. But we have a lot of Java people in market. Can we use Java people and upskill to Golang? Well, technically you can, but then you will invest in training, and that's not the core of the person. Many people would not like to switch the technologies, right? Because they have already gained a lot of skills in their own technology, which is Java for that matter. They would not like to switch. So how do we solve this problem? When we are into microservices, we can hire people of different technologies and ask them to create a microservice in their own technology, what they love. So at this moment, let us say we are finding more Java people. Although our whole application or the other application is built using Golang, we can build this specific microservice of for delivering the food. So all the food management capabilities, all those microservices we can build in Java, and we can still deliver within times. Another advantage of making our application technology independent is, let's say, if we see Amazon, or if we see Netflix, there are a lot of different types of uh, things that the application is doing. It is talking to doing some logging in. it is talking to some external services, it is doing some, let's say, it has some products. So basically, it has a lot of data, structured data. And which database suits best for structured data? The SQL database, maybe MS SQL, Oracle, MySQL. These databases are best suited when you have a structured data in your application. But the same applications also serve for analytics. They also serve for, let's say, searching, right? So you need to be storing data in different formats. So definitely there's a use case for NoSQL databases here as well. If we talk about Python and compare it with Java, right? Python is much more efficient. You'll find a lot of different tools for analytics purposes. Maybe you want to use R for analytics, right? Um, in case of monolithic application, you are tightly coupled with one technology. You cannot mix multiple technologies together. Or when we talk about microservices architecture, here we can use our own technologies. We can take advantage of best of all the worlds that we have. We can use R for analytics. We can use Java for object-oriented program. We can use NoSQL for analytics. We can use SQL for structured database. So a whole lot of all the different technologies we can mix and match and create an application which works best. Each component of the application works best by itself. Such applications are highly scalable because they're not tightly coupled. You can throw away any service which is not working and bring up new service there. You can have multiple instances of the same service running. For example, if we see any application, login service is the one which is under most pressure because everyone has to log in to access any portion of that. But once people log in, they will move away to the specific portions of their choices. They might want to take a look at their own choice of movies in Netflix. They might want to go directly to the cart for their saved items in Amazon, right? So basically, the different impacts. Not everybody does the same thing after logging in, but login, everyone has to do it. If we were in monolithic application, we had to scale the whole application just to cater the needs of our login service. But when we are in microservice, we just have to scale up our login service and whole application works well. So the bottleneck of login service we have removed by using microservices. In the long term, this is really cost effective. You just need to replicate a couple of servers and all your microservices work while catering to the demand of each portion of your application to its customers. So there are a lot of advantages of microservices, which means should every application that we create should be on microservices. Is that true? The answer to that is no. Microservice is not one solution fits all kind of a solution. There are a lot of problems which come when we try to solve these kind of solutions. So we should go to microservices only when we have a very a requirement of very highly scalable application. When we have when the number of users is very high, in that case only we need to go to microservices. This is true for Amazon. This is true for Netflix, where there are a lot of people who are going in and then um, purchasing stuff from there. But if you talk about a small application, maybe a small school which has, let's say, 20,000 odd users, out of them maybe, let's say, 500 or few would be active at any given time. Do we really need to scale up to microservices? I don't think so. That's not what we want really. Monolithic works fine in those cases. So these are the complexities which come in case of microservices. What we see is, uh, let's say we have a mobile application. This mobile application needs to know what's the location of the service that it wants to consume. And if we have 10,000 microservices, the mobile application needs to know about those 10,000 microservices so that it can consume those services. There are solutions to this. We are going to talk them about. We have many solutions. We are going to talk about the solutions provided by Netflix for these complexities in some time. Then becomes the difficulty of service discovery. So, for example, uh, there's my Amazon app is up and running. It is working fine, and suddenly I'll take the older example. I need new services for food delivery, right? The mobile application should be aware that there is a new microservice available. That is how I will be able to invoke it. Or maybe any customer, any client who needs to be aware about the new services which are upcoming, right? So we need to solve that problem about the new services which are upcoming in my microservices architecture. When we talked about login, we need to load balance between them. Let's say we have 5 microservices running only to cater our login functionality. Remember, we said that login functionality is always under pressure, so we would need definitely more than one login services running behind the same service, replication of same service. But there are two different servers which are catering to the same business behavior. So we need to load balance between them. We don't want one microservice to be under heavy load and the other one sitting idle. We want an idle load balancing between them. Then let's say there's one of our microservice has stopped responding. There is a, let's say, Stack Overflow error. It has been running for quite some time. Stack Overflow error, and now it is accepting your request, but it's just heating up. It's keep on waiting. How long would you want to wait there? Would you like to wait for 2 minutes, 20 minutes, 40 minutes? You need some kind of a circuit breaker there, because if you see browsers and other clients, and they have a circuit breaker by default. So let's say sometimes we get a timeout error, right? These timeout error arise when you are on a network thing, and microservices talk to each other via REST APIs, via network, right? But if you were monolithic, these were just a method calls, no timeout. But in case of microservices, we need to take care that the circuit breaks. We need to take care that we don't have to wait forever for a service to respond. If something is not responding, not responding, right? Now imagine the same service which went down, which is not responding, and there are 1,000s of microservices which are running. How would you identify which service is not running? Logging, identifying the matrices becomes a very, very difficult task in case of microservices. So many microservices are running. One of them is giving the error. Which one you don't know. You have to traverse through all your network and find it out. So finding matrices and logging becomes really difficult in case of microservices. So these were some problems which microservices initiators like Netflix or Amazon faced earlier, and they find out a solution for them. Each of these difficulties have been solved and fixed by Netflix with one of the components. On a very high level, I'm going to introduce you to the Netflix OSS. Netflix OSS, when we talk about Zool, Zool is a gateway. This is the entry point of all your APIs. Now, we are solving the first problem here to have a single entry point for the clients, let's say the mobile application. Now, when we have a gateway, when we have Zool system, when we have a Zool server up and running, mobile applications need to know only about one server, which is Zool. All other complexity is abstracted behind the scenes. No client does not know where these services, who is responding these services, what the items are coming from. For me, Zool is the single entry point, which is running on X server. All other services might be running on a Y, Z, or any different number of servers. There could be multiple things. All that complexity is handled and hidden by Zool, which is also known as gateway. Zool is dependent upon some other services for service discovery, which is known as Eureka. अगर हम यूरेका की बात करते हैं, it's like I think I'm not sure. I think it was Archimedes or someone who wanted to check the मुकुट का weight. So there was a king. उसका सोने का weight उसको देखना था कि ये असली है या नकली है. तो उसने पानी में dip किया उसको और देखा कि okay, how much water is it displacing, right? So by the weight of the water which the mukut was displacing, वो आइडेंटिफाई कर पाया कि जो मुकुट असली है कि नकली है, and he was able to prove that this mukut is fake and this is the real one. So he was basically able to identify that. He found this out while he was bathing, and then he ran away naked and shouting यूरेका यूरेका यूरेका, right? यूरेका का मतलब है फाइंड करना, डिस्कवरी करना, मिल गया. वही कहना चाहता है कि मुझे सॉल्यूशन मिल गया, आई फाउंड द सॉल्यूशन. सो यूरेका मीन्स फाइंडिंग, डिस्कवरी, एंड दिस इज व्हाट एग्जैक्टली व्हाट इट डज. यूरेका हेल्प्स अस इन डिस्कवरिंग न्यू सर्विसेज. जूल को नहीं पता कि नई सर्विस आ रही है कि नहीं आ रही, वो एक्सपोज कर रहा है. ठीक है, अगर कोई कोई उसके पास रिक्वेस्ट आती है तो वो सही माइक्रो सर्विस को एक्सपोज करेगा, बट नई माइक्रो सर्विस जो भी अप एंड रनिंग होती है उसको वो नहीं फाइंड आउट कर सकता. उसके लिए हमें यूरेका पे डिपेंड करना पड़ता है. तो जूल इज अवर गेटवे, यूरेका इज अवर सर्विस डिस्कवरी, जो कि हमें नई अपकमिंग सर्विसेज को फाइंड आउट करके हमें बताती है कि ये नई माइक्रो सर्विसेज आ गए हैं, एंड देन यू कैन एक्सपोज दैट. रिबन इज फॉर लोड बैलेंसिंग. जस्ट लाइक तराजू में एक रिबन रहता है, किस तरफ वेट ज्यादा करना है, किस तरफ कम करना है, एंड यू कैन कंट्रोल दैट वाया द रिबन, राइट? This is exactly what it does. This will control the load that we are facing. किस microservice को कितना देना है, all of them is managed by this component which is called as ribbon. This could be part of Zool or this could be outside Zool depending upon requirements, how heavy your requirement is, how heavy your need for ribbon is, but this can be deployed as a different component as well. Then we have a component which is known as hysterics, circuit breaker. जो हम बात कर रहे थे सर्किट ब्रेकर, यहाँ पर कौन से, अगर लेट्स से देयर इज अ माइक्रो सर्विस व्हिच वेंट डाउन, वो माइक्रो सर्विस जो है रिस्पॉन्ड नहीं कर रही है, तो हमें कहीं ना कहीं अपना कनेक्शन तोड़ना पड़ेगा. कब तोड़ना है, कैसे तोड़ना है, इट इज यूरेका, सॉरी इट्स हिस्टेरिक्स दैट वी नीड टू that handles that. Okay. Eureka client is, I think I should not have called it out separately because it's very linked and tightly coupled to Eureka. But Eureka client is deployed separately as part of services, as part of gateway. All the services which needs to be discovered have Eureka client in that. I will show this code in some time, and then I think it will be much more clear. But yes, this is another component that we have. देन टर्बाइन इज यूज्ड फॉर स्ट्रीमिंग. अगर हमने देखा कि हमारे पास मल्टीपल इतनी सारी सर्विसेज हैं, उनको स्ट्रीम करना है, उनके मैट्रिसेस क्या है, वो एक साथ देखना मुश्किल हो जाता है. दैट इज वेयर टर्बाइन हेल्प्स अस टू streamline the multiple matrices that we have. Zipkin is used for logging purposes. अगर हमारे पास बहुत सारे logs आ रहे हैं, उनको कैसे मैनेज करना है, यहाँ पर हम Zipkin को यूज करेंगे. तो ये हमारी बहुत सारी कंपोनेंट्स हैं जो नेटफ्लिक्स ओएसएस ने दिया है. इसके अलावा और भी कंपोनेंट्स हैं, बट हम हाई लेवल पर सिर्फ इन्हीं कंपोनेंट्स के बारे में बात करेंगे. तो हमने देखा इन कंपोनेंट्स को, और अब हम देखते हैं हाई लेवल आर्किटेक्चर पे नेटफ्लिक्स आर्किटेक्चर कैसा दिखाई देता है. हाई लेवल आर्किटेक्चर पे ये हमारा सर्विस कंज्यूमर है. दिस कुड बी अ वेब एप्लीकेशन, इट कुड बी अ मोबाइल एप्लीकेशन, इट कुड बी एनी थर्ड पार्टी वेंडर हु इज ट्राइंग टू access our APIs, but he needs to know only one thing, which is our edge server or gateway or Netflix Zool. तो जो टेक्नोलॉजी है जिसको इसका नाम नेटफ्लिक्स ने दिया वो है Zool, बट जो एक काम कर रहा है उसको कभी कभी हम एज सर्वर बोल देते हैं, कभी कभी हम इसको गेटवे बोल देते हैं, बिकॉज दिस लाइज ऑन अ एज एंड दिस एक्ट्स एज अ गेटवे, सिंगल पॉइंट एंट्री पॉइंट है. तो जो भी हमारा कस्टमर होगा, जो भी क्लाइंट होगा, वो एज सर्वर या गेटवे से हमारी एप्लीकेशन में एंटर करेगा. जूल जो है जनरली रिबन हम इसके अंदर रखते हैं, बट अगर आप इसको चाहें तो एक अलग कंपोनेंट की तरह डिप्लॉय भी कर सकते हैं. रिबन क्या है, ये हमारा लोड बैलेंसर है. जितनी हमारी मल्टीपल सर्विसेज डिप्लॉयड हैं, उनमें किस तरीके से हमें लोड को बैलेंस करना है, रिबन टेक्स केयर ऑफ इट. जूल की एक शॉर्टकमिंग है, वो नई सर्विसेज को डिस्कवर नहीं कर सकता. उसके लिए वो हमारी सर्विस डिस्कवरी या फिर यूरेका, जो कि टेक्नोलॉजी का नाम है यूरेका, उसके ऊपर डिपेंडेंट है. एज सर्वर सर्विस डिस्कवरी से बात करेगा to find out what are the new services, and then we will expose them to the outer world, basically to the clients. And behind the scenes we have all our microservices which were deployed. So you see there we can have n number of microservices there which have their own database system, which they have their own technology. All of them talk to each other via REST APIs, and then it is exposed outside. So this diagram is on a very high level, which depicts our Netflix architecture. Now let's enter our code base. What is meant by this? In this architecture, if you see, I have few different components which are built on Netflix OSS. This is an open source software which is also available on GitHub if you like, and you'll be able to find that out. You can simply download this stuff. I will share the links in some time. But yeah, you can see that there are. This is composed of a lot of different applications. ये वही एप्लीकेशन है जो मोनोलिथिक एप्लीकेशन अगर मैं बनाता तो मुझे सिर्फ एक ही कोड बेस बनाना पड़ता बट नाउ बिकॉज वी आर इन माइक्रो सर्विसेज आर्किटेक्चर आई हैव सो मेनी डिफरेंट microservices workspaces for that matter. Each one of them is a Maven project. Each microservice that you see here, demo catalog, demo customer, Eureka server, Zool server, all of them are individual code bases. They're individually deployable components, and ideally they should be in a different code bases themselves. And they could be in any different technologies. For simplicity, I'm using the same architecture, which is Java and Spring Boot, but they can be in any technology of your choice. So let's see here. We will start with our discovery system, which is microservices demo Eureka server. See, we have our microservices demo Eureka server. हमें यहाँ पर server चाहिए. Okay, this is a dependency which is from a Netflix OSS. Then we might need some tests if we want to write some test cases and some binding API binding for connecting to other services. But apart from that, nothing much is required. We might need a plugin for building up the different things which contains both core and client. But main important thing is this dependency that we need. If we go and check its code base, because this is just a hello world and a dummy application, my Eureka server consists of only one class, and if that needs to be counted, that is less than 15 lines, including the spaces. This annotation, enable Eureka server, does all the magic. I don't need anything else, any other Java code to create a Eureka server. I might need some configurations though. I'll come to those configurations. Uh, First, let's see what is this bootstrap.yaml. So just like properties file, we have YAML file. You can use properties if you like. This YAML is more used these days because it's more expressive. It needs less space to bundle. You don't have to repeat the things, and it's kind of a hierarchical, so it's cooler. That is why it's in use now. Bootstrap.yaml is very specific to any microservice that you create, including Eureka or Zool. Remember, both Eureka and Zool are themselves as a microservice, where they are solving a specific business requirement. Eureka wants to be a service discovery, right? Each microservice should be named. Why it should be named, I'll come back to you soon. I'll show you why. But every microservice should have some name which is relevant to what it is doing. Uh, for simplicity, we have called it as Eureka. We are saying that cloud config is not required. Cloud config is another component which Netflix OSS provide. You can host your configuration outside on a cloud and you can change at the runtime. I'm not demonstrating that at the moment. I'm just keeping it simple. So cloud config is not enabled here. Apart from that, we have an application YAML. This application YAML is environment based. You can have multiple application.yamls based upon the environment that you are deploying your application on. Your dev environment could have different thing. Your QA would have different thing. Based upon that, you can define different application.yamls. And interestingly, all our applications, all our SDKs that we are going to use, for example, Spring Boot, can also refer to application.yaml. So for example, server port is actually a Spring Boot component, which means that we are running our application on port number 8761. This is also the default port for Eureka, which they have defined. We have mentioned that register with Eureka. I don't want to register myself on Eureka. I've kept it false, and then there are some wait time. You can define some things according to the business requirement. I'm keeping it simple. I'm keeping the default values which I get in application.yaml. Uh, not much complexity. So if you see these five or six, one, two, three, actually three uh, three files comprise of my whole Eureka server, which is doing a lot of things. Thanks to these dependencies, a lot of things has already been done by Netflix and provided as a war to me. So that is already done. I just have to make use of it. Similar to Eureka, we do have Zool, which is our gateway. Let's go and check what this comprises of. If we see here, this requires some of our web components if required. This component needs a Eureka client. So remember when we were in our presentation, we talked about Eureka server and Eureka client. These two components are tightly coupled with each other. But apart from that, having these dependencies makes all our applications highly loosely coupled. So you should have a corresponding client with each Eureka server. And what you do is you just add a dependency, and this will automatically connect your application to client to Eureka server. Okay, you don't have to do anything else. Everything else is taken care by both these dependencies, server on Eureka server and client on any other application which you want to expose via Eureka client. If we go and check our Zool, if you see, very similar to Eureka server, everything else has already been done by Netflix. I don't have to do a lot of things. If I need a simple application, just this annotation works for me. Apart from that, what you see on board is a very simple Spring Boot application with just the default file which is downloaded from start.spring.io. Just this annotation makes my application as a Zool proxy. I might need some additional configurations here. This is my bootstrap.yaml where I need to define the name of the service. The name of this service is Zool at the moment, and I've kept everything very simple. One thing which is additional in all the Eureka client applications is I need to define where my Eureka server is hosted. So this is a property of Eureka client where we tell where is our Eureka service hosted. And remember, we mentioned the port number 8761. So this is where our service is being hosted. And if we see application.yaml, this particular service gateway is running on port number 8080. And there are some other instances if you want, the logging level and the other things. We will drill down in them in a later point of stage, but these are some things which are optional. We can provide as per our convenience. We do not provide them also. It should work. Yeah, the gateway should work at least. These APIs might not work, but yeah, gateway would work for you. So we have created two very basic and very important components of our whole architecture. We have created our Zool architecture, which is the gateway. We have created the Eureka server, which is our service discovery. We also have Turbine, which is used for creating matrices. I'm not going into detail at the moment. More important thing is all our other services. So if you see microservice demo catalog, microservice demo customer, microservice demo order, these are some simple microservices which are giving us some business functionalities. Catalog app holds a catalog app. This is nothing more than a Spring Boot microservice application. This is indeed a microservice application, which you see it has a controller, it gives some business functionalities, whatever according to our business requirement. So at this moment, as part of our discussion, what this microservice is doing is not important. I hope you are very well aware about how to create a microservice, how to create any application for that matter. You get the requirement, you build that. Important is how do we expose this microservice to our gateway and Eureka. If we see bootstrap.properties, see the difference. Earlier we were using YAML, here we are using properties. So it's not a hardbound rule. You can have your own methodologies, whatever you like. You can, if you want, you can still use YAML here. If you want, you can use properties depending upon the service owner's preferences. You can use your implementations. You can also have different technologies altogether, as I called out earlier. So all of them don't know what technology the other service is built upon. Important thing is that it should be having its own, it should know where my Eureka service is running. It should tell what is its name. It should tell how many instances and the various configuration, which is business specific thing it need to be done. Just we need to tell, okay, where are we going to run this particular application. Similar to this, we have other microservices, catalog, customer, which are also deployed on different applications. They have their own names and they have their own components, this property. And how it is being defined, it depends upon yourself. You define the name, you define the Eureka server, and you add the Eureka client dependency. It would work then and there. Now let's see this in action. I have created, I'm running these services on a Docker file. We're using Docker. I'll just demonstrate it to you where they are. Here's my Docker Compose YAML where I'm building different services on Docker. I'm exposing the port so that it feels like all of them is running on my host network. And I've created the different links here. We're running the different services, all of them working together. All of them are running here. You can see the logs here. What I want to show you is, if you see, there are different microservices which are running in their own Docker image, but I'm going to expose them and I'm going to fetch them from my discovery and from my gateway. So first of all, I'm going to my local host and my service discovery, which is running on port number 8761. I'm going to make a hit there. On the server, when I hit, we see a default page. This default page shows me the different applications which are running. And this is why the name is important. The names which you see here are coming from their application name properties. So each service needs to have a name so that this name could be visible and I can identify what a particular item is doing. If you see, there are different types of informations which are available. It is telling, okay, these are the different services which are running. They are up at the moment. If you switch one off, you will see the status will change to down. Why is this possible? Because there are a lot of matrices which are also created when we are creating our microservices, and Netflix Eureka is able to read those matrices and give us some output like this. Okay, so if we see our Zool is running on port number 8080, and if I open up, it opens up a info page. Let's see what info does it brings. It should generally bring if the service is up or not. If you see behind, there should be some logs which are going, which are calling, not loading. Not important. Important thing is if to hit my actual service, which is running on 8080 without any parameter. Let me try with 8080. So when I do a local host 8080, I will land up with a page which is present in my gateway because this is what I am hitting here. But then I would also show you how I am accessing the different APIs there. So while this page is loading, I think I'm running out of memory here. But if you see, there is a statics page inside my Zool, and that contains one index.html. As you are aware, index runs on default slash. What we see here is a customer list.html, catalog list.html. Where are these pages hosted? These pages are not present in our gateway system. These pages are present in their individual microservices. So if we go to, let's say, customer, and if we go to templates, you see we have a customer.html. We have a customer list.html. We have some other pages which are present in this microservice. But we will pretty soon see how are we going to access the same content or same APIs which are exposed by these services which we have created via gateway. So what we see here is we have our page which is loaded where we see the different components. This view is coming still from gateway. This is coming from our this one Zool, and we have index.html. This is the page which we are seeing online. We see the order processing, we see customer list, all of them are visible from this page. However, when I click on customer, just observe the URL. The URL becomes slash customer and slash list. I think there is read timeout if you see. So microservices has its own disadvantages. Things can break down in between, and then you need to work upon. If you see, uh, read timeout is coming from hysterics, which is our circuit breaker, which we were talking about. Whenever there is a service which is responding slow, we see that the response is the hysterics comes into picture and breaks it so that we do not keep on waiting everywhere. Let's just check what do we see. We see customer up, but why is it not visible? Yeah. You see, we observed that the timeout of hysterics is quite fast. It breaks things before the service was able to respond, right? So the service was up, but because of network errors, the values which we have defined by default in hysterics is so low that it was not letting it respond. So these are some nuances of microservices that you need to be aware of. What is the right value for read timeout? You need to decide. And if you see customer view all, this page is actually coming from customer list, which is not at all present in gateway. This view is not present in gateway. We only have index.html, which has only this portion. It is referring to the view in our customer service. This is our customer service, and we have customer list.html, which is showing us the list of all of our customers. Let's see, we see customer view all, and then we have add customer um, button or row something here. We have customer view all, we have add customer. If you want to observe our APIs, I'll just show you the network console. And if I click on add customer, there are some requests which are going behind the scenes, and these services are actually going to customer service. Yes. Okay, so this has redirected me to a different API. No service involved. Just add my name for that matter. I'll fill it up, and I'm going to submit it. If you see, the form has been submitted. The action was successful. This is the success thing that we are seeing. Everything is being handled by our customer service, which is there. All these items, the success thing that we see, the form that we are going to see, all of these things are being handled by uh, this microservice, but we are not accessing this microservice directly. If you see our Docker file, these microservices that we have, they are not even exposed. They are inside our Docker image. They have their own Docker image. All these microservices have their own Docker image, but they are linked to Eureka. When they are linked to Eureka, service discovery is possible. Service discovery is open. Another thing which is open is our Zool gateway. So we hit our Zool gateway. The Zool gateway goes to service discovery for discovering these microservices and then expose them via the API that we have. Let's go back in general. This is our customer, basically our browser where from where we were hitting. We were entering the gateway of our services, which is at Zool, which is running on port number 8080. This ad server has a load balancer and hysterics inbuilt, so it is managing itself. But if you want, you can have a separate ribbon and hysterics deployed. Ad server talks to Eureka, which is also available on public, which we saw. We were able to see a screen from Eureka. All the other things are in their own DMZ. They are their own Docker images, which we were not even accessing them, but they were being exposed via service. So they were being discovered via service discovery, and then edge server was able to connect to them and then expose them to the outer network. What I demonstrated you was a very simple demo application, Hello World application, where all the services are running on the same server, which is my laptop. But in the real world, it will never happen. All these microservices will be deployed on their individual network, individual systems, but still work exactly the same way because we were using all that configuration in our code. For example, if you see, all the services know where they need to deploy, where is Eureka deployed, and it is by chance that they all are on the same network. This is this was from my side today. We discussed about Eureka. We discussed about Azul. We discussed about some other components like hysterics and ribbon. Discussed how these applications are deployed in Netflix architecture system. Why are microservices important? What are the nuances of microservices? When to go with microservice and when to go for monolithic application? I made this video specifically for you, for people who were not able to join. If you have any questions, please do let me know. I would be happy to help you. You have my number already, so please feel free to connect me.